Hey guys, Randy Richard in the shop. So I'm going to go over the Lance lathe, the repair here we're going to make for the taper attachment. So we repaired or I should say didn't repair, but we added the base to the dividing head. So those are in the center are within a few thousandths, pretty much right on the money as far as the heights go. So, I mean, I was able to adjust it to 0, basically, by just a slight touch on the angle of the head. I haven't confirmed that it's square yet, but anyway, onto the lathe. So I showed before the taper attachment, how it's attached on the lathe through a dovetail slide, and the locking mechanisms. I had popped them out. So here's one of the screws for the locking mechanism, and on top of that was an aluminum piece. Now there's 2 of these. It has a 30-degree or 60-degree dovetail notch in there to match the dovetail, and you can see how they're smashed, deformed. They're just too soft of material to be in there. It's pretty poor. I don't know if these are original or not, but they're pretty worn, they're smashed and deformed. They go in here and you screw them up, and they go up at an angle and close it up on that dovetail edge. So I got a couple hunks of brass. We're gonna make a couple new ones. I'm actually gonna make them a tiny bit longer, about 1/4 inch longer actually on the top here. So this is not so uptight. I mean, it's almost all the threads are up in there. So I'm going to give it a little bit of room, add a 1/4 inch to the length. So I got a piece of 1 3/8 brass here. We'll machine up. So that's what we're going to do in this video. And we'll make 2 of those for the lathe. After we get that done, we'll get the setup. It'll probably be in the next video, but we'll do the setup for making the mandrel and getting the taper cut on the mandrel, and we'll use the taper attachment. So, and then after the mandrel's made, we'll be putting the gear on there, setting up on the mill, and brazing the teeth on the gear and milling those 2 teeth on the gear as a repair. So that's where we're going, and so let's get to work. Hey guys, I want to do something else with this taper attachment. These locking knobs also, a little addition here. So here's one of the knobs, and this thread. Well, let me tell you what I want to do is I want to clean this up. Somebody's been using pliers or pipe wrench or something on there, or it was probably knurled, just straight knurl originally. So what I think I'm going to do is I want to put it in the lathe to clean it up, and I'm going to cut, a scallop pattern around it. So to make it a little easier to grab, and especially with oily hands, gives you a little more grip. But I don't want to screw this up holding that in the lathe, like that. So I measured this, and this is 30 millimeter. It's just a smidge under, a couple 2/10 of a millimeter under that. Not tenths, 2/100 of a millimeter under that. 29, 0.45. 0.2995 millimeters. Not used to reading that. This is a Starrett dial caliper metric one, model number 120M. So it's 30 millimeters, but this is 1.5 millimeter pitch. Well, 30 millimeter, 1.5 millimeter, as far as I can tell, is not a standard metric pitch. So I need to know a few things I want to make a nut that I can chuck up in the lathe I'm just going to make it out of aluminum. So I can screw that in there, so I can hold this out from the chuck and not screw up the threads. And it will give me something when I mount it in the mill to hold it vertical, so I can go around with an end mill and cut those scallops. So I was doing some research a little bit, and one thing I have in my my reference manual is this sheet here from Carbide Depot that I've printed out, and it's for calculating inch or metric your your minor diameter, basically the hole size you need for a thread. But the nice thing about this calculation, it allows you to put in the percent thread engagement you want. Now in the machinery handbook, there is the calculation is pretty simple. The tap drill diameter is major diameter minus the pitch for a metric thread. Well, that comes out to be 28.5, and with this calculation using 70% engagement, I ended up at 28.636. That's 1.1274 inches. So it gives you a little more accurate result, diameter there. So it's percent thread engagement times the pitch divided by 76.98. So that's how I got my minor diameter to bore the hole out for this. In the machinery handbook, I'm using the 17th edition Machinery's Handbook. This is page 1191. And this is for international metric threads. And so they do have some formulas. But I needed also to know the depth of thread. So depth of thread, maximum depth of thread is 0.7035 times the pitch times 1.5. And the minimum is 0.6855 times the pitch. So I did that, ran those for a minimum maximum depth of thread, and I end up with 1.0553 millimeters for max, 1.0283 millimeters for minimum, and you can see there. So we got 41.5 thousandths and 40.5 thousandths for minimum maximum. So I know the bore hole I need to make, and I know my depth of thread, and I know the pitch. And so I'm ready to make this little part. So we'll go over to lathe and we'll get this done. Okay, I'm going to drill out this piece, and then bore it out to the proper dimension for the metric thread. Go a little deeper. All I need is about 3/4 of an inch of depth of thread. A little bit more. Do it. Now we got stuff to bore. Okay, I got it drilled out part way. I'm going to bore it out to 1.127, which is 28.636 millimeters. doing. Got the bottom nice and flat there. One, 2, 7. Good enough. That's what we wanted. Okay, so we've got a board, and we'll get set up to do some threading there. Okay, I've got everything set up here for the 1.5mm thread, ready to do the scratch pass. Now I'm going to do this slow because I leave the half nut engaged for the metric threads. Okay. And we're going to do that a little deeper there. I have a dial set up on the ways here. Use the dial in the ways to gauge the depth into the hole, right? And that looks right on the money. I can control the speed with the VFD real easy. So I can just slow her right down. So it stops real fast. A little more. There we go. That fits a little on the loose side, but one knob is actually larger than the other. By whoever made these, they didn't do a real good job. I think this is the 30 millimeter one. The other one's under 30, and that fits better actually. So I think I think that's gonna work there. Okay. That should work. Like I said, they don't look the best, but it's just something to hold it with. Really did a shitty job. They're kind of a little bit rough. Another fine example. This, by the way, this is my second try. The first one I really screwed it up, so because of that damn lever. So this will work for us, I think, though. As long as I can screw it down there and seat it on the bottom. I got the threads pretty far there, so. I'll put that in there. See what it looks like to run out. Not too bad. Not too bad really at all. I think this will work. I'll blow that out and get the rest of the crap out of there. But I think that's going to work. I'm going to set up here to do some. Okay, we got that thing screwed in there. We're going to try take a little facing cut on it, I think. And we're going to set up here to. Seems pretty solid. I have no idea what this is, but it's not hard. Not hard at all, so I'll cut those off of there, those knurls. And it won't look so bad. Still a little bit to go, right? Just that little bit. Oh, you can get a better finish on there, I think. Yeah, that's better. I did a little bit of polishing on there and broke it loose. Yeah, pretty good. I don't know, this material is kind of weird. Like it's harder in parts of it than others. It's probably just a piece of 1018. I hate 1018, but that's probably what it is. Okay, so that's that one's done. And I'm going to do the same thing to the other one.